I ain't gonna get a puppy. Ooh, 3 electrons.
Garrett, work on this.
Huh?
You weren't here yesterday. You should be working on this.
Yeah.
I wouldn't be copying down what, well, Friday that is.
You should be doing
I turn in tomorrow.
What Hannah's putting up here on the board.
True. Hannah's smart like that. Or is she? That's me.
I don't know, honestly.
Okay, did you just do phosphorus?
Yeah.
Excellent.
Shut up.
Alright, who can do silicon?
Not me. Yeah,
16
16.
over 15.
On the paper. Weird. Wait, Hannah, you mix up the, it's P and N.
And what I put.
You put N over P. Yeah, 16P.
Did you say more than that?
That's the wrong answer.
Should those be flipped?
Wrong answer.
Let me check and see if you're real quick.
Because on the paper it only has P over top of it and always.
Right, so phosphorus has
So it's actually 15.
atomic number 31, right?
Yep.
Correction, a mass number of 31 and atomic number of 15, so this is correct.
Okay.
See,
She just put the
Switch them
neutrons
around.
on the bottom. Alright, who can do silicon? Alright, so bell work question number 2 is talking about the valence electrons. They introduced this on the sheet here. They say valence electrons here. So what are the valence electrons? Might know? Okay, they are the outermost electrons. It's kind of like the clothing that you're wearing right now, the clothing that's on the outside really tells me a lot about you. Like Hannah's wearing a Louisville sweatshirt, tells me she supports Louisville. And Jake over there, he's wearing a beat team, so he's obviously against cancer. And Adam over here's got an Eastern Eagle shirt on, so he cares about Eastern. So the outside really determines the behavior. That's the whole point. We can predict your behavior based on what's on the outside.
Oh, I know. I mean,
So reading a book by its cover.
would be 8.
Yeah, the police will profile you if you didn't know this.
Yeah.
Like if you go into like an airport and you're wearing something that is like, you know, something they're looking for, and then they'll profile you. They'll pull you over and talk to you.
Cool drawing.
It's not against the law.
No, it is not. It's not against the law to profile people based on things that they're wearing.
Mm-hmm.
Yeah, they can.
That's just bad.
Well, I know, but it's you can.
He's wearing a tank top and no shorts. What is he doing?
When
you take that guy down.
Well, you have to remember
I
that.
tell him, please go rethink your life if you're walking outside.
He's probably on drugs. If somebody comes out in a tank top and underwear on.
Yeah. Tell
I
him
think it's acceptable.
All right, let's look at the family in groups, right? So this first group right here, they all tend to have one electron they want to lose. They have one on the outside, one valence electron. That is this first group here, one valence electron. The second group, how do you think it would have on the outside? 2. This one has 2 valence electrons. Now the transition metals, the ones in the middle, they are going to be discussed later. So we come over here to the second correction, the third main group, which is right here, number 13.
Oh, okay.
How many would you see here on the third group?
Probably like 13.
There are 3 because it's in the third group. So this group here would be aluminum. So up on the board there on your bell work it says determine the number of valence electrons for the following. Aluminum is going to have 3.
Okay, cool.
Okay?
Yeah.
So then you have carbon, which is in the fourth main group. How many is it going to have around it? 4.
Carbon.
Raise your hand for the fifth group, the nitrogen group. 5. I'll give you points if you raise your hand. And number 6, oxygen group, Michaela. And the fluorine group, Cody.
7.
And the last one, the helium group. Now helium only has 2, but the neon underneath of it. Let's go with Sophia. 8. Right, so there's a pattern here. And this pattern is based on what? John Newland's found this pattern. We talked about it a little bit on Friday, just to see if you remember.
I don't.
Anybody here playing music?
Yeah.
Oh, the whole
Yeah.
thing about the octaves and
Right,
stuff.
the octaves, the musical scale. So he's the one that came up with that. There are 8 basic notes in an octet, right?
Yeah.
So that's where the periodic table has its main group. They call it the law of the octaves. I'm gonna write that down. The law of the octaves. The law of the octaves basically tells you the valence electrons. Law of the octaves tells you the valence electrons. Really, I was listening to the news on I guess Sunday, and they were talking about this church shooting. I don't know if you were following the church shooting, and they were saying that if you see anybody on Facebook with like a picture of an AK-47, you should notify the police. So that's basically what I was just mentioning to you, that certain behaviors or pictures can sometimes give us an idea of people's behaviors.
It's like, but that's like a lot of the U.S. population. We have more guns than we do people. So.
Now, guns are very important. I would never vote to eliminate an American's ability to purchase a weapon and defend themselves. Because once again, it goes back to all men are created equal. It goes back to our Constitution. If you take guns away, then all men are not created equal. Because some people, just like professional football players, not everybody's going to be a professional football player because technically everybody's not created equal.
But everybody has to keep it.
No, not everybody has the ability to be a professional football player. You can go watch Rudy, like the Notre Dame episode. You can practice all you want.
I said a lot of people.
No. The vast majority of the population, just go to the mall and walk around. You'll see that there are very few professional football players walking around the mall.
Darn it.
All right, so Bell states, can 6, 8, or 10 electron wavelengths orbit the atom? Now, we read on Friday, right here, and I had you draw in your notes, n equals 3 and n equals 5. Do you remember drawing that in your notes?
Yeah.
Right? N equals 3, n equals 5. Well, we read up in the diagram that it says de Broglie saw that only odd numbers of wavelengths are allowed in a circular orbit of fixed radius. So he noticed that you could not put even numbers of wavelengths around the atom. Only odd numbers. That's an important thing to remember. Now when we start drawing the electron dot, right, this looks very different from the sheet that I handed you when we came in, when we're looking at the shapes of the atom, of the shells, right? So this looks very different compared to the Lewis dot structure. Now, why do we use the Lewis dot structure? Because it's an easier way for us to communicate where the electrons might be. So they're still moving in wave. We don't really know how close they are getting to the nucleus. We don't really know for sure whether they are moving to these lower energy levels and then coming back out. So if you look at like the P shape, it's on page 154. Look at page 154 real quick. It just looks to me, if you have the axis right at the center, like if I'm looking at the center of this graph, right? See the center of the graph? It would appear to me, if that was the nucleus, that the electron would be going close to the nucleus. So there's really a question mark, or a question that hasn't been answered. How far are the electrons traveling outside of the orbits naturally? The question is naturally. Are they traveling, from the 6th to the 5th to the 3rd naturally? Or are they just staying in the 6th energy level naturally? When we talk about these valence electrons, are they just staying in that valence shell naturally? That is, 100% of the time, are they staying in that shell? That's a question. We really don't know that for sure because they're drawing these diagrams to say that it's possible they could be going into the other orbitals naturally. That naturally we're saying in like a ground state that it's moving there. Right? Make sense?
Microscopic object that if I killed the rebellion, it's very small.
Okay, very good. So we're talking about the Heisenberg uncertainty principle, and the question is, what does that mean? What does the Heisenberg uncertainty principle state? Anybody know? Raise your hand. Points. Right out.
Fundamentally impossible to know precisely both the velocity and the position of the quantum.
All right. So why is that? Why is it impossible to know both of those at the same time? Jake? You know why it's impossible to know both at the same time? Anybody else? All right, Cody.
Is it because they move too fast?
Close. No. Kayla?
Maybe because when you move one, it just goes the other.
Right. It's because when you measure the electron, you're changing it. So you can see here in this diagram, basically, when a photon interacts with an electron at rest, both the velocity and the position of the electron are modified. So the problem is you're modifying them, and because you modify them, they're difficult to measure. It affects the measurement of them. So when you, right? So up here on the board, this is what Heisenberg looked like. There he is. So you can put a picture with the name. It's up here on the overhead. These are the 2 points. You can find out where the electron is, but not where it is going, or you can find out where the electron is going, but not where it is. That's because when you measure it, it's very small, and it's moving very fast. Okay. Heather, how many energy levels can we have?
It says 4, but I think it's more than 4.
How many do you think it's going to be?
I remember that one paper we got, there was like 7.
Right.
Seven.
That is correct, Heather. Good memory. So, what does the 7 correspond to?
The group.
No, you're close. Starts with a P. The periods. Right. So there are 7 periods in the periodic table. Remember that? You understand what that means? That's the horizontal
70 groupings.
rows. Right? There's 7 of them. If you look right here, it says 7. Right there. 7. All right. So we have 4 shown on the overhead. When we start examining the shapes, it's going to start on SP2, then it goes to SP3. So SP2 and the shapes, they provide us with a 90% probability of where the electron's going to be. Spherical shape. It's on 3 axes, the X, the Y, and the Z. Okay, so next we have the P shape. They consider it to be the dumbbell shape. Now, what does this mean right here? What does this large area mean right here and the less large? What does that mean, the difference in size? No, the probability. The probability is greater of finding it here and less in here. So that's what I was mentioning to you. We really aren't for sure that the electrons are even traveling in here because you get close there and there's like a 0% probability. These are basic probabilities. That's what the shapes represent to you. That's why we said 90% probability it's going to be found in that particular shape. So these are just regions. They're really not, they really don't define to us where the electrons are actually moving or how they're moving. They're just regions where we think they're going to be. That's why I go back to the book when I showed you the electrons moving around the nucleus. So is the d orbital more defined than the p orbital? Sophia, is the d orbital more defined than the p orbital? Does it look like it takes up more space? Okay, so why is that? Why is the d orbital more defined than the p? Now, how many different shapes are there in the d orbital?
Wait, no. Yes.
There are 5 different shapes. So how many electrons can you place in the d orbitals? 5 times 2. 10. So how many can you place in the p orbital? 3 times 2. How many can you place in the s orbital? 1 times 2. 2. So we're looking at the electrons now. How many?
7.
Right, so there are 7 different f
Oh,
orbitals. So the question is, how many electrons can be placed in those 7 different? How many?
14.
Very good, Garrett. Now, where would you usually find the f orbitals? What type of element is going to be positioned in an f and a d orbital? Anybody know? No, it would be the transition metals. Those are the ones in the middle of the periodic table. The S and the P are associated with the main group because they're predictable. The F and the D orbitals are a lot less predictable because there's just so many different areas where you can move electrons around. We call them trans. Branson, how many energy levels are there? No, there are 7. If you look on the periodic table, how many periods are on the periodic table?
7.
Right, there are 7 periods on the periodic table, Zane. You can see them by looking at the periodic table. There's 7. Right, see the number there? 7. Marcus, there are 7 periods. Right here. 7. Periods. Up on the board, where you see energy levels, there's actually 7 of those. They're only showing you 4 on the board here. So write that down. Electrons do not follow the orbital shape path. That is, the electron is not going to be following like this here. It doesn't follow these shapes up here. Because you would look at this and you'd be like, Mr. Steinecker, what is it doing there? How's the electron going to follow this shape? Right? It's not following that shape. These shapes tell you the probability the electron is going to be there. The electron is still following the circular path. That is, the circular path is the origin, and the electron is moving along that origin in that defined region. So it could come out, the probability of finding it there. Is everybody clear? It's not following that shape. That shape just tells you the probability of finding it there. It's following the circular origin. That is, the wave is following the circular origin around the nucleus. So the electron wants to stay in its energy level, like the 4th energy level. If it's moving in that energy level, it doesn't want to go out of that energy level. It's going to stay in that circular origin path. A quantum leap is what we call when the electron leaves that energy level, and it's considered to disappear and then reappear in another energy level. So it's not moving outside of that energy level. That's what the quantum leap states.
Function predicts a 3-dimensional region around the nucleus.
Okay, what element is that?
I don't know if it's right now.
Phosphorus? Very good. So phosphorus, miracle.
And like, the nurse was telling everybody to go to their rooms and lock the door because there was like a homeless man walking around asking people for money, and they ended up calling the police and they couldn't find him. But like, we stayed at like Best Western, so you know, like the doors are outside and stuff. And everybody was scared, so like they taped the doors shut. Like they were taping the doors shut. It was scary.
So I had 2 homeless experiences this weekend. The first one I talked to you about over at Myers, and the second one I was coming down the ramp over by Costco, and there was a guy. He had a UK shirt on, right? So when he walked by my car, guess what I did?
What?
I flashed him the U of L sign. I was like, "Go Cards!" If he had been UK, I might have given him $1. But I usually don't give people with homeless signs money, and the reason why I don't is you can go downtown if you are homeless and you can get into the residence programs. Well, they can get there. Right, hitchhiking. I'm just kidding.
If you want people money, but I doubt you're gonna let them in your car.
If they can find a way to stand where they're standing on the side of the road, they can find a way downtown.
How they're gonna walk down? Oh, I remember one
You
time.
don't just snap your fingers and become homeless. There's a lot of like hurdles that you.
I bet I could do that. I don't think it'd be that hard.
Okay, but anyway, here's the point. There are places you can go downtown if you're homeless. There's like Wayside Christian Mission. There's other things too that you can go. But they have rules there. People don't like following rules. That's the problem. Like when I was in the military, they had some very strict rules about what you could and couldn't do, and a lot of people didn't make it. Like 50% of the people that signed up for it, dropped out because it was just very stringent. Now, if you go downtown and you're signing up to be in the homeless population down there, those like wayside, they're not going to allow you to drink. They're not going to allow you to like be out at all hours in the morning, come in. Not going to allow you to do drugs. They're gonna examine you. They can sense things about you if they think you're on drugs. Yeah.
Ain't they gonna make you get a job?
They're going to help you. They're not going to make you. But they will do certain things to help you get a job, right, that suits you the best. So just remember that if you're struggling and you are at a tough place in your life, don't get involved in alcohol or drugs if you're at that point in your life, because it'll be much more difficult to get out of that point.
How do you feel about homeless people with animals? Because, like, I remember rolling past this guy, and he was homeless, and he had his dog, and his dog was just panning about him. And, like, the animal, like, he could have took it to, like, a homeless, like, a pet shelter or something, so it could, like, get water and stuff. But
Most homeless people migrate out to California. California probably has the largest homeless population because the weather is nice. Train. You can hop on a train.
I know a Greyhound.
Go to California. How do you know where?
The rules we'll read about tomorrow basically are associated with balance. So you can look along the X, Y, and the Z axis, and you'll see that this balance is where that circular origin is going to be found, and where the electrons will move in waves around those circular origins. They're not going to go outside their energy levels unless they are pushed. That's why you see less probability here. Can it be pushed in there? Yeah. So there's some probability if it's pushed there, but the majority of the time it's going to be found in its normal energy level.